Hey guys, the objectives for this video is we're going to be finding the total settlement. The steps are to find the initial stress. We're then going to be finding the final stress. We're going to be doing this using the effective stress equals the total stress minus the pore water pressure, which we developed in a couple series ago. We're then going to be finding the change in E using that graph and the equations we've developed, and then we're going to finally be finding the settlement. Okay, so here's our example. We've got a layer of gravel with a water table at 1 meter below the surface, and we've got a layer of clay. Okay. Now, we're not so concerned about the gravel settlement. Okay, it's not going to settle too much, but the clay will settle. Okay. So the first thing we need to do is that we always work at the center of the layer. Okay. So we come and draw a line. If this layer is 8 meters thick, we split it up into 4 meters and 4 meters. Okay, it's just the way it is that we work at the center. So let's call that A. Right? So we're always concerned, everything we do is based on the center of this layer, which is 4 meters. Okay, 4 meters is half of 8 meters. So let's draw what's happening. So because the water table is up here, it's going to cause everything below it to become saturated. Okay, and you can see in the question we're giving gamma dry, gamma sat. This is of the gravel, and we are not given gamma sat of the clay. Okay, so the first thing we're going to have to do is work that out. So we know that gamma sat equals G plus E on 1 plus E outside of gamma W, which would be 2.7 plus 0.8 on top of 1 plus 0.8 outside of gamma W, which is 9.81. Okay, this would equal around 19.06 kilonewtons per meter cubed. Okay, so we found gamma sat now to be 19.06. Now, what's going to happen is in this question is I'm going to word it like this. This is our initial situation. So initially we just have this. We have the water table here, and we're going to develop some effective stress at A. Then what's going to happen is that I'm going to come and put, say, I don't know, 4 meters of gravel, more gravel on top of this, right? So that's going to cause an increase in the vertical stress at point A. So we're going to find the vertical stress initially and the vertical stress finally. Okay, so you can see that in this question we're not given the vertical stresses. We're going to have to go find them, and then based on that we can find the change in E. Okay, so let's go ahead and do that. So for the initial conditions, so let's make this initial. We're going to be using the formula sigma V dash equals sigma V minus the pore water pressure. Okay, so the effective stress is the total stress minus the pore water pressure. So the total stress, we're going to come to our diagram, and we're going to see that we have 1 meter of dry gravel, 3 meters of saturated gravel, and 4 meters of saturated clay from A. Okay, we always go from the center of our layer, right? So this is going to look like, I'll try to fit it in here. So we have 1 meter of dry, so 1 times 19, plus 3 meters of saturated gravel, so the saturated of gravel is 21, so 3 by 21, plus 4 meters of saturated clay. Okay, so 4 by 19.06. Okay, and if we work this out, so it would be 19 plus 3 by 21 plus 4 by 1906 is 158.2 kPa. Okay, now the pore water pressure. So how many meters of pore water pressure do we have? We have, from below the water table, we have 3 plus 4, so 7 meters. So it would be 7 by 9.81, because this is gamma WZ here, which equals 7 by 9 is 68.7. Okay, which means we can find our total effective stress of 158.2 minus 68.7 is 89.5. Okay, so that's the initial conditions. Now for the final conditions. So now let's say we come and put 4 meters of gravel on top of this, right? So we have an additional 4 meters of gravel, okay, above our initial surface. So sigma V now is going to equal 1 plus 4, so 5 meters of gravel, plus everything else is the same. 3 by 21 of saturated gravel and 4 by 4 lots of saturated clay. Okay, so 3 by 21 plus 4 by 1906. So it's essentially 158.2. It's the same answer plus 4 lots of 19. Okay, or you can go ahead and calculate it the way I've written it out. So we get 234.2. All right. So now we can find the pore water pressure, which is going to be the exact same. There's no change in pore water pressure at A. The water table has remained where it is. Nothing's changed. So this is still 68.7, which means we can find the total effective stress. Sorry, the effective stress, which would be 234.2 minus 68.7 is 165.5. Okay, so we've increased our stress from 89.5 to 165.5. Now we need to go and find the change in E. So the thing you always need to know is what values are we going to be using? Is it CR, CC? Are we normally consolidated? Are we over consolidated? Or are we both? Okay, so I haven't actually said anything in the question yet, but I'm going to say that let's make the pre-consolidated stress at A. Let's give that to us as, one sec, I just need to choose a value which is going to be nice for this example. Let's make it at 120 kPa. Okay, so the pre-consolidated stress at A is 120 kPa, which means that if we look at all our values, our sigma initial is equal to 89.5. Our sigma final dash is equal to 165.5, and our sigma pre-consolidated is 120. Okay, so we are actually between, our pre-consolidated stress is between our initial and final, which means we're both over-consolidated and normally consolidated, right? So we're going to have to go and find the change in E, knowing all this stuff, right? So let's quickly do that. So we know that our graph is going to look something like this. Okay, so we have this and this. Okay, we know that our initial is 89.5, our pre-consolidated is 120, and our final is 165.5. Okay, this value is the CR value, and this value is the CC value. Okay, because this is the over-consolidated section, and this is the normally consolidated section. Okay, so we're going to go find our change in E, or we're going to find, this is our initial void ratio, let's call that E1 and E2. So we're going to go find E2 now, right? So we know that E1 will equal minus CR log sigma PC dash on sigma I dash plus the initial void ratio, okay, which we can calculate. CR we gave to ourselves in the example was, have I defined CR anywhere? No, I haven't defined CR anywhere. Okay, so I'm going to have to define CR. Let's make CR equal to 0.08 and CC equal to 0.1. Okay, so CR is 0, so minus 0.08 log sigma PC dash is 120 on 89.5 plus the initial voids ratio, which in our question is 0.8. So plus 0.8. So if we work this out, it's going to be minus 0.0 log of 120 divided 89.5 plus 0.8. So we get 0.79. We can then work out E2, so now we're along this line. So it's going to be minus CC. CC is 0.1. So minus CC log sigma final is 165.5. Sigma initial is the pre-consolidated stress of 120 plus the initial void ratio, which in our case is E1. So that'll be 0.79. So we get minus 0.1 log of 165.5 divided by 120 plus 0.79 is 0.78. Okay, so there's E2. Okay, so we know that our initial void ratio was 0.8, was given to us in the question, and we just find that our final void ratio E2 is 0.78. Okay, so EF is 0.78. Okay, we know that our layer thickness is 8 meters. Okay, we know that our initial void ratio is 0.8. I just repeated that. Okay, fine. So we can then go and find the settlement. We know the settlement is equal to minus the change in E H over 1 plus the initial void ratio. So this will be minus. So we need to find change in E. So change in E is EF minus EI, which is 0.78 minus 0.8, which is minus 0.02. So this is minus 0.02. H is the layer thickness, which is 8 meters, over 1 plus the initial void ratio, which is 0.8. We can go ahead and calculate this. We get minus 0.00889 meters, which would be this is positive, which would be the same as 88.9 millimeters. Okay, so once again, just recapping what we did, because it was quite a long process. Because we weren't given the stresses in our situation, we had to go ahead and calculate the initial stress and the final stress. We then saw those and compared it to the pre-consolidation stress to determine whether we were overly consolidated, normally consolidated, or in our case we were both, because the pre-consolidated stress was between the initial and final. We then found the final void ratio, which allowed us to find the change in void ratio, okay, EF minus EI, which then allowed us to find the settlement. Okay, I need to remind you that you're always going from the center of the layer, but just remember H is the total layer thickness. So H is not 4 meters, H is 8 meters. Alright guys, I hope that helps.